Hi and welcome to my channel. In today's video we are going to look at inspection settings on checkpoint security gateways. Inspection settings control how the gateway analyzes network traffic, including checking for threats, protocol violations, and ensuring secure VoIP communications. So in Smart Console we have our inspection settings here. So we can click here and we can see that we have this window opens. So by default, the gateway comes with two profiles. And by profiles, we mean here. The default inspection, which this is this one, so default inspection, which provides basic protection, and the recommended one, or the recommended inspection, which applies stricter rules. You can also create your own custom profile. So if you click here, you can create your own profile. So you can create your own custom profile to fine-tune exactly what the gateway inspects. But remember, any changes to inspection settings only take effect after you install the access control policy. So the gateway can start enforcing the rules the traffic passing through it. So let's go back to the general. So inspection settings rules are applied before access control policy. So traffic is hitting here first before the access control policy. These are part of the protocol parser, anomaly detection engine, which operates during the initial traffic parsing phase. So for example, inspection settings, for example, let's take a look at, for example, non-compliant. We can see the performance impact here. So some of them are drop, some of them are inactive, are not used, and some of them are accept. So these trigger during packet parsing before the traffic reaches the rule base. So as an example, a malformed HTTP header, as this one, or a chunked encoding violations, or invalid end of line characters. So if a packet violates these rules and the action is set to drop, as we can see here, it is discarded immediately. No further policy evaluation occurs. And when it comes to the access control policy, it is evaluated after traffic passes protocol parsing here and inspection. And there you can determine whether traffic is allowed based on source destination, service application, or identity and time. So okay, inspection settings allow you to define how the security gateway analyzes and controls network traffic. These settings here, let's remove this. So these settings are grouped into different categories. The first one is deep packet inspection, or DPI, which inspects the payload of packets for threats, malware, and protocol violations. The other one is protocol parsing inspection, which examines protocol-specific traffic to ensure compliance with standards and detect anomalies or malicious activities. And third and lastly is VoIP packet inspection, specifically analyzes VoIP traffic to ensure secure and reliable voice communication. So the security management server provides, as we said, two pre-configured inspection profiles. The first one is the default inspection, which is enabled automatically when you first configure a security gateway. Provides a baseline level of inspection suitable for most environments. The recommended inspection offers stricter inspection settings and is optimized for stronger security policies. So you can also create, as we said, a custom inspection profile tailored to your environment, which allows you to fine-tune each inspection category, enable or disable specific protocol. So for example, let's again compliant I should say here, so non-compliant. So for example, if you want to allow this for any reason, you can double click on it and then override the action and choose to accept or inactive, and log on or not, or choose any action that you maybe like. And here we have many different options, and these are so applied to R70 and above. So yes, so once you assign an inspection profile, a default or recommended or custom, to a security gateway, the settings only take effect after you install the access control policy. This ensures that traffic passing through the gateway is analyzed according to the selected inspection rules. So additional considerations. You can assign different inspection profiles to different gateways. So here, as we can see, we have gateways. So in my case, I have only one cluster, but in production, maybe you have many, and you can then apply. So for example, here we can see that it is assigned policy, the recommended. You can click on edit and choose here default or recommended. And if you have more custom profiles, you can choose from them and apply them on your gateway. So if you have many gateways, you can apply different policies on different gateways, depending on their role. So the role of the gateways in the network, for example, perimeter versus internal. So regularly review inspection profile to ensure they remain aligned with current threat intelligence and organizational security policies. Combining protocol inspection with application control and URL filtering strengthens the overall security posture of the gateway. So now, time to do some hands-on lab to see how inspection settings work. But first, let's take a look at exceptions. Here you can create an exception. So let's click on one. So you choose the what profile, and you choose the protection. For example, let's choose none and see, take that one. And you choose network, what network. So in this way, you can choose to create an exception for maybe one source. If you have one source that have this problem, but you know that this source is not a problem or is not risky, so you can create an exception to bypass the inspection settings. So back to our hands-on lab. So now it's time to do some hands-on labs to see how inspection settings work. We will use a crafted command sent to a broken HTTP request to the web server. So let's take a look at this very not interesting topology, but as you can see, we have a victim behind the gateway, and the gateway is connected to the internet, and then we have this attacker here. So very simple diagram. So we will craft HTTP request to the web server. So here I got a web server to test how the firewall reacts. But first, let's run a legitimate HTTP request and see how the gateway reacts. So this server has the IP of, let's type here, 114. And this one has the IP of 10.225, something like that. So let's jump on to my machine here. Let's make this a full screen. IP config here, and we can see that this device has the IP of 10.114. and we can SSH to our attack machine, which is 10.2.2.5, which is an Ubuntu machine. Okay, so let's get our, so first we have a command which will check if if we send a legitimate HTTP request and to see how the gateway reacts. So this one and this curl command. So let's run that command and we get some result here. So now let's head back to our gateway and let's shut down this and go to logs. And we can do this to see. So we are searching for our victim server and HTTP traffic. And we can see that everything is accept, because here, as you can see, I'm accepting everything. So everything is accepted. This is weird, but because this is a lab, so I accept everything just to demonstrate this situation. So back to the logs. Okay, let's run that again. So surely new logs will show up here. As we can see, this one. So now to test our, but here let's check what profile is installed, because the default will allow these packets, the non-HTTP compliant. So we are running a recommended inspection, so we will see some drops when we send this kind of traffic. Let's do this only once and see the result. Just wait a sec here, and here it is. And if we append this one, you can directly see, we scroll a little bit down, protection name non-compliant HTTP. So this, okay, if we back there, what did this do? So the printf creates the raw HTTP request manually. Post HTTP 1.1 means we are sending post request to the root page. And host 10.1.1.4 tells the server's IP address. Now, content length ABC. This part is intentionally wrong. It should be a number, but we wrote ABC to make the request invalid. So, because the request is invalid, a security gateway like Checkpoint can detect it as non-compliant HTTP. So this is just an example on how it works. To demonstrate that this, click again here. Let's run that one again. And let's head back to our, let's shut this down. And you see, again. So now every time we send this, it will be dropped. So let's run it many times and back to our, and let's wait a sec here. As you can see, drop. So this is how it's work, and this is done before the access policy, because as we have seen here, the access policy is only accept. So this takes action before the access policy, as we can see, as we have seen on the logs. We have many drops, and that's because this is invalid HTTP request. And here this ABC is invalid. There we should have numbers. And this is a way, this is how hackers try to get inside your systems by using these kinds of HTTP posts. So be aware of it. So with this done, so our video is done here. I hope that is useful. So thank you for watching and see you in the next video.